If you stood on the summit of Olympus Mons, you wouldn't know you were standing on a mountain at all. There would be no peak to look up at, no valley waiting below, just an endless, gently curving plain stretching away in every direction until, impossibly far off, the horizon quietly bends and disappears. That's the strange thing about the largest mountain in the solar system. It's so wide that its own curve begins to compete with the curve of the planet beneath it. You would be standing on top of a volcano so enormous you couldn't actually see it. Not from the ground, not even from the mountain itself. This is Olympus Mons, the tallest known mountain in our entire solar system, roughly 70,000 feet high, 2.5 times the height of Mount Everest, and nearly 400 miles wide enough to cover the entire country of Italy. One single mountain, with an entire European nation resting comfortably beneath its base. But the real question was never how big is it. The real question is this. On a small, cold, red planet, half the size of our own, how did something this monstrous ever get built? What happened on Mars that never happened here on Earth? That's what we're going to find out. Before we can understand Olympus Mons, we need to understand the ground it's standing on. Mars is our neighbor, roughly half the size of Earth. And its famous red color isn't some cosmic mystery, it's rust, literally. The soil is rich in iron, and over billions of years, that iron has slowly oxidized, turned red, the way an old nail left out in the rain turns orange. In a very real sense, the entire planet is rusted. Today, Mars is cold, dry, nearly lifeless. Its atmosphere is so thin, less than 1% the thickness of Earth's, that liquid water simply cannot survive on the surface. It either freezes solid or boils away into vapor almost instantly. Temperatures regularly plunge far below zero. But it wasn't always like this. The evidence is written into the landscape itself. Dried riverbeds, ancient lake basins, geological formations that could only have been carved by flowing water. Billions of years ago, Mars had rivers. It had lakes. Some scientists believe it may even have had an ocean. Somewhere along the way, it lost almost all of it. The water disappeared, the atmosphere thinned, and the planet slowly transformed into the desert we see today. But there's one thing Mars never lost. One thing that makes it one of the strangest volcanic worlds we know of. And that is exactly why Olympus Mons exists. On the Martian surface lies a vast region called the Tharsis Bulge. A raised plateau, home to some of the largest volcanoes ever discovered, and ruling over all of them is Olympus Mons. The secret to its shape lies in the lava itself. The lava that built this mountain wasn't thick. It wasn't slow-moving or sluggish. It was thin, almost watery, and it moved fast. Lava like that doesn't pile up in one place. It spreads. It travels for hundreds of miles, laying down a thin, wide sheet before it finally cools. Olympus Mons is the result of countless layers like that. Sheet after sheet after sheet, stacking on top of one another for over 1 billion years. That's why the mountain isn't sharp or jagged. Its average slope is only about 5 degrees, so gentle that if you were walking on it, You might not even feel like you were climbing. From above, it doesn't look like a peak at all. It looks like an enormous shield resting on the ground. That's actually its official classification, a shield volcano. Earth has these too. Hawaii's Mauna Loa is the largest one we have. And Olympus Mons is roughly 100 times bigger, which brings us to the real puzzle. The lava on Mars behaves the same way lava behaves here on Earth. Same process, same material. So why did Mars end up with a mountain 100 times larger? The answer isn't in the lava. It's in the ground the lava was falling on. Look at the islands of Hawaii. A neat chain of extinct volcanoes, one after another, stretching across the ocean. That chain exists because Earth's surface is constantly moving. Deep below, a stationary source of heat, a hotspot, stays fixed in place. But the crust above it keeps sliding, inch by inch, year after year. Every few 100,000 years, the old volcano drifts away from its heat source and goes dormant. A little further along, a brand new one is born. Earth's tectonic plates never allow a single volcano to grow to its full ultimate potential. They're always being cut off, always moving on. Mars broke that rule. Completely. Mars has no tectonic plates, no moving crust. The entire planet's surface is one solid, motionless shell. So when a heat source ignited deep inside Mars, the ground above it never drifted away. Not for a few 100,000 years. Not for a few million. For over 1 billion years. The exact same vent. The exact same spot. Fed by an uninterrupted, endless supply of lava rising from below. Energy that on Earth would have been divided between 10 different volcanoes, scattered across a slowly shifting surface. On Mars, it all gathered in a single unmoving point. And there was a second force working in its favor. Mars has weaker gravity, only about 1/3 of Earth's. Weaker gravity means a mountain isn't crushed under its own weight. It can keep rising and rising. Far higher than anything gravity would allow here on Earth. A motionless crust anchored the lava in one place. Weak gravity let it climb without limit. The result was a mountain that, physically, could never have existed on our planet. Any traveler approaching Olympus Mons wouldn't first encounter its summit. They'd first encounter its wall. The edges of this mountain don't gently taper down to meet the surrounding plains. Instead, there's a sheer vertical cliff in places, nearly 5 miles high, just slightly shorter than the height of Everest's summit itself. But this isn't a mountain. This is just the edge of one. A wall so tall that if you stood at its base and looked straight up, the sky itself would seem to simply run out. Scientists call this feature an escarpment, and it remains one of the mountain's most puzzling mysteries. How does a volcano with such a gentle 5-degree slope suddenly end in a wall this violent? Some researchers believe the mountain's edges collapsed under their own immense weight, colossal landslides, possibly among the largest that have ever occurred anywhere on Mars. Others propose something far more startling. That ice, or even standing water, once surrounded this volcano and slowly carved these cliffs away over time. That second theory is the more thrilling one, because if it's true, it means Olympus Mons once rose out of an ocean or stood at the edge of a great ice sheet, a burning peak rising from the middle of a frozen world. It's a sight no living thing will ever witness again. But the evidence for it may still be written into that wall to this very day. No, let's go up, all the way up, 70,000 feet to the summit. At this altitude, Mars's already thin atmosphere has nearly vanished entirely. A person standing here would look up into a sky that stays almost black, even at midday. The stars might be visible even at noon. Air pressure here is so low. This location, while technically still on the ground, is functionally almost the edge of space itself. The great dust storms that periodically engulf the entire planet of Mars, most of them never even reach this high. Down below, a storm might be raging across the whole world. While up here, the summit stands in complete, undisturbed silence. And then, right at the peak, the ground simply vanishes. A massive crater opens up before you. The caldera, roughly 50 miles across and nearly 2 miles deep. This is where, once, an ocean of molten rock churned and boiled. When the magma chamber underneath finally drained, the roof of that molten sea collapsed under its own weight, leaving behind this colossal scar. Look closer, and you'll notice it isn't one crater at all. It's several, overlapping one inside another, one stacked upon the last. Each one is the signature of a different eruption, from a different chapter in this mountain's history. The summit isn't just a peak. It's a history book, written entirely in stone. And the very last page of that book raises the biggest question of all. When did this fire last burn? One way scientists read the age of a planetary surface is by counting impact craters. Older terrain accumulates more of them over time. Younger terrain has far fewer. When researchers ran this count on certain slopes of Olympus Mons, the results stunned them. Some of these lava flows had remarkably few craters, so few that the flows appeared to be only a few million years old. On the scale of the universe's history, a few million years is essentially yesterday evening, which means one thing. Olympus Mons is very likely not dead. It's sleeping, somewhere deep beneath its surface. Heat may still linger. A reservoir of magma, breathing slowly, patiently, waiting. It's entirely possible that millions of years from now, it could wake again, and the largest mountain in the solar system could once more breathe fire. And in 2022, scientists found another clue supporting this. NASA's InSight lander detected Marsquakes originating deep within the planet, evidence that the heart of Mars hasn't gone completely cold. But let's be honest here. All of this is possibility, not proof. No human being has ever watched Olympus Mons erupt. It's entirely possible that it will remain silent throughout the whole of human civilization. And yet, that single possibility changes everything about how we see this mountain. This isn't a ruin. It isn't simply a monument to something that used to be. It might be a sleeping giant, quietly, patiently waiting for its turn. Now, imagine the future. A human colonist, someday, steps out from a settlement on Mars and decides to climb Olympus Mons. Here's the surprising part. This climb wouldn't be anything like scaling Everest. There would be no sheer cliffs to fight through, assuming they found a way through that towering 5-mile wall. No sudden avalanches. No treacherous ice to slip on. Just an endless, gentle slope, 5 degrees, stretching on for hundreds of miles. The real enemy wouldn't be the incline. It would be the distance. The journey from base to summit would take weeks, and at every step, that climber would have to carry or manufacture their own air, their own water, their own food. Nighttime temperatures on Mars can fall to nearly 150 degrees below 0 Fahrenheit, and that's before accounting for radiation exposure with no thick atmosphere to shield them. This wouldn't be mountaineering, in any sense we understand it today. It would be a long, solitary expedition across a tilted, alien world, where the destination is visible every single day, yet somehow never seems to get any closer. But the person who finally stands at the edge of that caldera will be standing at the highest known point in the entire solar system. Beneath their feet, 13 miles of solid stone. Above their head, a black, star-filled sky. And in front of them, a 50-mile-wide crater where an ocean of fire once raged. The first climbers of Everest have their names written permanently into history. The name of whoever first stands atop Olympus Mons hasn't been written yet. Olympus Mons doesn't stand alone. It rises at the edge of Tharsis, and Tharsis itself is the most extraordinary region on the entire planet. It's a massive bulge on the Martian surface, swollen by billions of years of volcanic activity. And rising from that same bulge are 3 more enormous volcanoes: Arsia Mons, Pavonis Mons, and Ascraeus Mons, standing in an almost perfectly straight line, as if someone had measured and placed them deliberately. Each one of these, on its own, would dwarf any mountain on Earth. Standing next to Olympus Mons, though, they look almost small. The sheer weight of Tharsis is so enormous that scientists believe its formation actually shifted the planet's rotational balance. The entire planet tilted slightly on its axis under the strain, and that same stress tore open one of the most staggering features anywhere in the solar system: Valles Marineris, a canyon system stretching nearly 2,500 miles, long enough that, if you laid it across the continental United States, it would stretch from coast to coast. Next to it, our own Grand Canyon looks like little more than a scratch in the dirt. Olympus Mons, then, isn't the story of one isolated event. It's the tallest signature of an entire era, a time when this small red planet was still deeply, violently alive on the inside. So, in the end, what does Olympus Mons tell us? It isn't simply a record. It's a planet's autobiography, written in solid rock. Every layer inside it is a witness to an age when Mars still burned on the inside, when water may still have run across its surface, when this small, distant world might have genuinely resembled a twin of our own Earth. Then Mars cooled. Its atmosphere drifted away into space. Its rivers dried into dust. But its greatest monument remained standing. And in that, there's a quiet lesson. The exact same process, the same lava, the same heat, the same physics builds a chain of modest volcanoes here on Earth, and, on Mars, built a single, towering giant. The difference was never the ingredients. It was the circumstances. A moving crust versus a motionless one. Strong gravity versus weak. The laws of physics are the same everywhere in the universe, but the outcomes belong entirely to each individual world. That's why every planet, every moon, every world out there is its own unfinished story waiting for someone someday to read it. Perhaps, sometime this century, a human being will take the first step onto that gentle red slope. Perhaps a rover will finally descend into that caldera, read the age of its rock, and tell us at long last exactly when that fire last burned. Until then, Olympus Mons will simply keep standing exactly where it has stood for 1 billion years, silent, immense, and holding within itself the entire history of a world